refractive index is a very important property of materials that are destined for optical applications, such as being able to make a very thin optical lens or making your hair shiny with the right kind of shampoo or conditioner. BINOL is an interesting compound. It's available in both enantiomeric forms and is widely used for doing enantioselective synthesis. But our interest was more in its very high refractive index. Since silicones are already used in optical applications, could we make better materials by incorporating BINOL to increase the refractive index of silicone from about 1.4 up to a much higher level? The chemistry is easy. Do a Piers-Rubinsztajn reaction with a commercial hydrogen-terminated silicone in the presence of this boron catalyst and an alternating copolymer forms with a BINOL group and then this blue silicone. Obviously, the less of that blue silicone, the higher will be the refractive index, but in our hands, the silicone chain needed to be at least about 10 units long, or else we just didn't make nice materials. We made oligomers, presumably cyclic materials. However, when the chain was as low as 13, now the refractive index was much higher than 1.4. It was 1.54. To improve yet the refractive index, we had to find alternative ways of doing it. One is to incorporate comonomers like this diaryl compound, which has a much higher refractive index. And the second thing was to take silicones like this, where 2 of the 4 silicones had aromatic groups on them, now combine them with this BINOL structure that has got some dilution provided by these dimethyl compounds. But the reason they're there is these alkoxysilanes allow us to do cross-linking chemistry. So now we have BINOL, the green dimethylsilicones, the light blue phenylmethylsilicones, leading to an elastomer with an overall refractive index of 1.58. Not quite as high as we would have liked, but the chemistry is extremely easy and adaptable, we think, to other kinds of optical applications. The paper can be seen here in Macromolecular Rapid Communications. Thank you very much for your attention.